Hey everybody. What we're going to do next in chapter 4 is going to be changing gears a little bit. So far we've been taking quadratic equations that we usually wanted to set equal to 0 and solve for x because they were, just quadratic equations, and they only had, the x variable. Well, now what we're going to do is we're going to talk a little bit about, what if it was a quadratic function, meaning you now had like the x variable and the y variable, okay? So it's not really going to be equal to, well, I'm not going to say that just now. But I will say our main skill we're trying to get a grip on is going to be graphing these quadratic functions. We're still going to be we're still going to be working with equations, just these equations are now going to have both an x variable and a y variable, which opens up the door to graphing it in the xy plane. Standard form, kind of already know about that. Ax squared plus bx plus c. Not so much equals 0, but equals, y. Remember, f of x, you can just pretty much refer to as y. So y equals ax squared plus bx plus c. Quadratic term, linear term, constant term. A lot of this, I apologize, in the times we're in right now, but we're going to sort of skip these things. So again, all this stuff skipping, and we're going to get to the graphing. So here we go. The graph of a quadratic function we call a parabola, meaning these U-shaped graphs. When you graph a quadratic function, it's going to make this parabola U shape. All right? And these U graphs, these parabolas, are going to have, definite noteworthy points, okay, and noteworthy things. There's going to be things of note in these graphs. One thing is the vertex, the point that's at the absolute bottom of the parabola, or at the absolute top where it actually changes direction, we call the vertex. And this invisible line, and I emphasis on the word like invisible, because it's not really there. This vertical line right there, this purple line, is not really there in the graph, but it's the line that goes right down the middle of the parabola, and we call this the axis of symmetry. It's actually a pretty good name if you think about it. Axis, because it's kind of like this line, and of symmetry because these U-shaped graphs are symmetrical, right? Anyway, not going to linger on that too much. Another thing about these parabola graphs is they can have minimum values, right? If you have a right side up U shape, like your basic U shape, it's going to have an absolute lowest point. Like it reaches its lowest point before it goes up again. So that's why we use the word minimum. All right. And the lowest it goes, we're talking about its y value. So for this particular example, the lowest y value it really hits is, it looks like -3. See right here at -3. Oh, okay, so you can fill that in yourself. I thought I was going to say it right there. But you can write that in yourself. It's going to be a minimum value of -3 at x equals, well, what would be the x coordinate of this minimum? Looks like about 1.5. So a minimum value of -3 at x equals 1.5, or at least that's what, best guess. But if our U shape, if our parabola is like upside down, then it's going to have an absolute highest point, which what other M word talks about highest? We have minimums and we only have maximums. So once again, the maximum value is going to be like the y coordinate. So I would say like the y coordinate here, like, because how high it goes, I would say 1, 2, like we could say 2.5. Am I right? 1, 2, like 2.5. So its maximum value is 2.5. At x equals, looks like we could say x equals -1. At x equals -1. It ain't? So those are the basics, like of a parabola. You have vertex, you have axis of symmetry, and they can have maximums and they can have minimums. Now here's how we actually go about graphing. Now, what's the word? Like disclaimer, like just kind of a disclaimer here, a heads up. For your actual homework assignments, and if we take a quiz or a test on this stuff, not everyone is going to be able to print out and have like really nice graph paper or a printed out grid or something. So we're actually not going to expect you, like I'm not going to hold you to actually drawing these graphs, okay? But we are going to have you answer questions, in some kind of way. Like you might actually not be literally drawing the graph, but you're still going to have to point out what the vertex is going to be and what the axis of symmetry is going to be or something. Maybe a couple other points. Anyway, here we go. Here's how you do it. Pay really close attention to these steps. Okay, here we go. So if I give you a quadratic function, represented by an equation, it's still an equation, but it represents a function. So it's, anyway, whatever. Semantics. So I'm giving you this quadratic function, and this is important. You ready? It's in standard form. Because guess what? Later in the next lesson, I'm going to be talking about how we graph it when it's given to you in another form. There's another form that you could get this in. Okay, but for right now, standard form. So here's what you do. You look at this as in standard form, which again is ax squared plus bx plus c, equals y. And the first thing you do is you find the axis of symmetry. Well, how am I supposed to do that, you might ask? How are you supposed to find the axis of symmetry? Well, there happens to be a formula to do it. So this formula is clutch. Very useful. So to find the axis of symmetry, you're literally going to use this formula every time. -b over 2a. Where are you going to get the b? Where are you going to get the a? From your standard form equation. So from here, remember it went ax squared plus bx plus c. So our b value was -2. Our b is going to be -2. And our a value is going to be 1, which is invisible, but it's there. 1x squared, okay? So again, we have a negative that's built into the formula, and then the b value was -2, like I just said, and the a value is 1, like I just said. And when you crunch all this together, -2 divided by 2, which is -1, but then you have a negative out in front there, so the final answer is +1. Okay? So the formula did its job. And what do we have now? We have the axis of symmetry, which is x equals 1. That's how you say it. You say x equals 1 because technically the axis of symmetry is a vertical line. And that's how you describe vertical lines, by saying x equals something. So I'm going to go ahead and, again, you don't have to like literally do this on your assignments, but I'm going to go ahead and show you this, and you would actually now graph your axis of symmetry, okay? That's step 1. Step 2 is we're going to find, the other half of the vertex. And the reason I say that is because, guess what? We know that our vertex has to be somewhere on this axis of symmetry. So we already kind of know, the x-coordinate of our vertex. In other words, our vertex is going to be 1 comma something, because it's got to go somewhere on this axis of symmetry. So here's how we find that question mark, okay? Here's how we find the other half of our vertex. We take this value of 1 and we just plug it in to the original equation, just like that. So it's going to be y equals 1, so you get it, 1 x squared minus 2 times 1 and stuff. And when you crunch all that out, 1 squared is 1, minus 2 times 10, you end up getting negative 4. So our vertex is 1 comma negative 4. So right there. There's our vertex. Okay? And the third thing that we do is we just kind of plot a couple more points. We can actually plot as many other points as we want. Like we could plug in whatever we want to get like additional points. Now, remember, it's really important knowing which point is the vertex. So you got to go through these couple of steps to figure out what point is actually the vertex. You know what I mean? You wouldn't just want to guess and check. You wouldn't just want to plug in a bunch of random x values and just sort of like guess which one is like the all-important vertex. But now that we know what the vertex is, we can just plug in whatever other values we want for x to get other points. Hey, kind of like making a table of points, like you've done a bunch of other times in your life. That's kind of what we're going to do. Now, make it easy on yourself. Plot the y-intercept, for example. What do I mean by this, really? Okay, make it easy on yourself. Plug in what? What would be the easiest number if you have that choice? What would be the easiest number to plug in for x, do you think, to get another point? Well, I hope you're thinking 0. Plugging in 0 is going to be the easiest thing for you to do. Okay? And that's actually going to get you technically your y-intercept. But so here we go. 0 squared minus 2 times 0 minus 3. That's going to get you negative 3. So another point that we have is going to be 0 comma negative 3, right there. 0 comma negative 3 is going to be another point. Now, here's how we find a third point. Since we know that this is going to be a U-shape, a symmetrical, keyword symmetrical, a symmetrical parabola, a U, if that's a point, then guess what? We know that we just reflect it to the other side of the U, and this must also be a point. So you would write down, not only is 0 comma negative 3 a point, but so is 2 comma negative 3. So there you go. And I mean, what color could I pick here? I don't know. I'll just whatever pick this. So I mean, now if you had to, you could like sketch. This is ugly as heck, but sorry. You could like sketch your U. I can't leave that there. That's so ugly. But you could actually now just, you know, you don't need to have like a like 50,000 dots to just sketch your U. You know, you could just sketch your U. And since you know that the purple dots go there and your U shape would be, you know, right side up, you could say that this function has a what? A minimum or a maximum? It would have a minimum. It would have anyway, but we'll get there. Let's do a couple more examples quick. So here we go. We have another example of a quadratic function that is in standard form. Yay! It's in standard form. We can know A and B and C. And once again, here's your strategy. You first use the formula to find your axis of symmetry. So what's my B value? What is it? Negative 12. What's my A value? What's my A value? Negative 3. So you plug that stuff in, and you end up getting, let's see, negative 12 over a negative 6. That's going to be positive, but then there's a negative out in front, and so, whoa, okay. And so your axis of symmetry is, remember, don't forget the x. Yeah. What the? I'm sorry. Don't forget the x equals negative 2. All right? And so if we were going to actually graph this, we have an axis of symmetry right there. All right, what we do next is, remember, what do we do next? We have to finish our vertex. So we take this value and we plug it in to the original equation. Right? So what are we plugging in here? Negative 2. Remember, it's a different equation every time. So you got to use like the equation you're working with at the time, okay? Plug in negative 2 in for this equation. And now you just got to like not screw up anything with your negatives, right? Negative 2 squared is positive 4. You know what I mean? And then here, for example, we have like a negative 12 times a negative 2. Just don't screw up your negatives. Okay? And so you end up at the end of the day here with negative 1. So remember, what that means is, I know you're writing this down, so I'm trying to, I mean, you can pause the video if you need to, but what this means is you now have your vertex being negative 2 comma negative 1. So you could, like, you know, plot that if you needed to. And then the other thing you would do is just like plot a couple other more points, you know? Plug in whatever x value you want in for here. I mean, obviously it can't be negative 2 because you already did that to get your vertex. But, you know, again, if 0 is still, you know, an option, if 0 is still on the table, just plug in 0. It's the easiest thing ever to plug in. Because 0 squared is 0, times negative 3 is still 0, negative 12 times 0 is 0, and so you end up just getting negative 13. Which means that 0 comma negative 13 is another point. You know, and again, it's actually going to be, since it's 0 comma something, it's going to be your y-intercept. So, oh my gosh, negative 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I mean, if I miscounted, I don't care. And so 0 comma negative 13 is one of your points, and so that means another point would have to go, it would have to reflect perfectly to the other side of, look, of the U. So it looks like here, check this out, looks like here we're going to have an upside down U. You could actually, I mean, we're not actually drawing this because, you know, we're, you know, with this distance learning and stuff, but this would be your U, and it's going to be upside down, which means it would have a maximum value here. The maximum value of -1. Remember, your min or your max, your minimum or your maximum value is always going to be the y-coordinate of your vertex. I mean, think about it. That almost makes too much sense. Okay? And so what? You would say your third point would be what? -4, -13. So there would be your 3 points, that you could just kind of, we're not trying to overdo this or go overboard with this. So, hey, now, to plant a seed in your brain stem, this parabola ended up being upside down. Do you think it had anything to do with this negative way out in front? Think about it. Just again, planting a seed for later. Okay, so one more of these. You know what? I'm going to skip this. It's not worth it. It's not difficult. Okay, like it's not like I'm skipping it because it's way too tough. It's just it's actually a little bit counterproductive. I know that won't probably make that much sense to you right now, but bottom line is skip. And what I'm going to do next is I'm going to show you how I want you doing the homework. Okay, so our homework, I'm going to try to make it easy on you. I hope this is making it easier on you. I'm going to have you just do it on a Google Doc. All right, so here's what your Google Doc I think is going to look like. So here's what you're going to do. The directions here at first. So you got the first half. Anyway, you'll see. So the first set of directions say identify the vertex, the axis of symmetry, the maximum or minimum value, and the range of each parabola. So I'm going to do a couple of these for free. I'm going to give you a couple freebies here, so you're definitely going to want to stay with me here. So the finding the range, as in like the domain and range, which is the range, that's optional. Again, I'm picking my battles here in our situation. So I'm going to leave, if you want to find the range, I'll leave it optional to you. So here's how you would do these ones, okay? What I have here is probably the work that you would do. I mean, you can't really do this without doing like little scratch work. So this is basically the scratch work that you would be doing like on separate paper. You don't need to type this out. Good Lord. I mean, no, please don't do that to yourself. You would probably write this down on separate paper, but I don't need to see it. You know what I mean? I'm just showing you this is kind of what you would write down on separate paper, okay? You would do the axis of symmetry formula, and on this number 8, you would end up with -1. So here's what you do. You would watch. You would click here, and you would type in x equals -1. Okay, that's what you do. Once you figure out that the axis of symmetry is x equals -1, and then you would move on in order to like pretty much find the vertex. Oh my god, man, what the heck, man? Whoa. That's funny how this should probably be in a different order. Well, it's too late. Anyway, that's the axis of symmetry. And then when you go on to do all this mathematics to figure out that your y-coordinate would be 0, and so then you type on your vertex -1, 0. Okay, and you just type that in there once you figure out what the vertex is. Now, look what I did here. I plugged in 0. Okay, wait. Why did I do that? Oh, I know why I did that here. So check this out. Because the next thing you got to do is you got to find the max or the min. All right? You don't know whether it's a max or a min unless you know whether or not your parabola is upside down or not. So I did this last piece of business to figure out, like, so here's the vertex. This would be another point, and if this is like another point, compared to the vertex, you know that the parabola is curling up, and it's going to be right side up. So that way you know it's going to be a min. All right? Okay? And since it's a min of what? Well, you're always just going to go with that value. The y-coordinate of your vertex. So we have a minimum value of 0. Again, since the vertex is going to be at -1, 0, and this point pretty much says that we're going to be opening up and have a regular right side up U shape. And so that means we're going to have a minimum of 0. Now your range, again, this is optional, but since it's a U shape that's opening up, I would do bracket, I would do 0, comma, and then this is actually going to infinity. How can I do this? Insert, maybe like a special character. I'm trying to type infinity. So over here, you could go to, is there math somewhere? Arrow, over here maybe. There we go. Over here we can make it the math drop down, and where's infinity? It's gotta be somewhere. You probably see it and I don't right now. There it is! Click on it and there it is. Again, optional, but if you think you want to, whatever. So that's how you would do problems like number 8. You would do this on scratch paper and then just kind of type in your 3 answers right here, okay? For all of these. There's not that many. Then you get down to like number 17, okay? And I'm going to do the first one for you, and there's a handful of these. There's like 5 or whatever, 6 maybe, I don't know. So here's how you do number 17. Once again, this is like the scratch work that you would do just on like separate paper. So you're supposed to like graph these, but again, we're not really going to graph them unless you want to. I mean, whatever. But I'm trying to make it easy on you with this Google Doc, okay? But I'm just going to leave this here for reference, so you can kind of like have something to look at, you know what I mean? Like a visual aid. Because once you do this math and you figure out that the axis of symmetry is -3, which leads to a vertex of -3, 0. So you go down here and you type in whatever you find. In this case, it'd be -3, 0. Then you're supposed to find 2 other points. That's where this comes into play. Okay? So we typed in 0 because it's the easiest thing. You can type in whatever you want, but you should, when you take it from me, you should try 0. And you end up with 9. And so that means another point is 0, 9. Now remember, how do we get like a third point? Well, remember, and this is why I'm leaving you with these things to kind of look at. If you had a vertex of -3, 0 right there, okay, and you had another point of like 0, 9, so -3, 0, 0, 9, wouldn't you have to go like another 1, 2, 3 up here? So right here, would be another point, okay? And it looks like that would be -6, okay, 9. And so you type that in, and that's done now. That's done. All right, and that's how you do all these other ones, just by typing that in, okay? Hope that helped a lot. Good luck on the homework.